All right, so today we're going to continue looking at our properties of exponents. Before we get started, I would like you to try these warm-up problems. So pause the video so that you can try a couple of these, and then you can restart it, and I'll go over a couple of these questions real quick before we get started on the new material for today. All right, so hopefully you went through and tried a couple of these problems. Now I'd like to go through just a couple of them real quick as a little bit of review, and this is going over some things that we saw right before breaks or a couple of review pieces here. Again, we're looking at exponents, which are those numbers up above our number. That's our repeated multiplication. So when we see that exponent, that means that we're taking that x and multiplying it by itself that many times. So this would be x times x. This one would be x times x times x. And these numbers or values that have the exponent attached to them are called monomials. And we're going to continue looking at working with monomials and using different properties with these values. Anytime that we multiply monomials together, our base number, that number with the exponent attached to it, remains the same. And if we're multiplying, we're going to add our exponents together. We also looked at dividing monomials, and when we divided, our base number stayed the same, and we subtracted our exponents. So on each of these, our base number would stay the same, and we would add those exponents together. On number 4, pay attention to that first value there. Again, one of the main mistakes that we see here is forgetting that a number without an exponent, we can always assume that there's a 1 there. So when we put those together, this would be w to the 5th. Okay, so make sure that you keep that 1 on any number that doesn't have an exponent attached to it. And then if you tried this number 5, the first rectangle would be 3 times larger than the second. You'd have 96 divided by 32 for your two areas. All right, so our new standard today is going to be looking at another property of exponents. This property is called the power of a power property. Again, power is a different word that we can use for exponents. So this property is called power of a power. It's kind of like an exponent to another exponent or a double exponent, which will make more sense once we see a couple of them. And again, we're using these to simplify expressions, not to solve expressions. So our final answer on these is still going to have an exponent in it. We're not going to solve it out to a number answer. So on this first example, again, we have right here is what we call a power of a power. So we have 8 to the 6th power. And then on the outside of that parentheses, that whole value is then being taken to a second exponent. So this is where the name of the property comes in as a power of a power, because we have an exponent to another exponent. Or we could look at this as a double exponent. Anytime that we have that double exponent, where we have this 8 to the 6th power going to a second exponent, we're going to take our two exponent values and we're going to multiply these together. So this is equal to 8 to the 6th times 3. And when we multiply those together, we can simplify this out as 8 to the 18th. Again, as I mentioned before, these are asking us to simplify, not to solve. So we're not going to solve this out and get a number answer here. Instead, we're going to leave this in simplest exponent terms, and we're going to leave our answer as 8 to the 18th. Okay, so for each of these problems, we will be solving it out and leaving it in terms of an exponent. All right, so this second example is popping up. What I'd like you to do again is pause the video real quick, try this second example, and then you can restart your video and see if you got this one right. So again, we have power of a power. Again, kind of refer to these as that double exponent, where those two exponents are going to be right next to each other in that problem. So we have 2 to the 5th power, and then again, that whole value is going to the second exponent to the 3rd. When we have that power of a power, our base number, just like it did when we did multiplication and division, that base number stays the same. Okay, but on power of a power, we're going to take those exponents and multiply them together. So 5 times 3 is 15. 2 remains our base number. And again, we're simplifying this in exponent terms, so we would simplify that out as 2 to the 15th. And that would be our answer. We wouldn't go any further than that. We would leave our answer as 2 to the 15th. Just like was true with our multiplication and division, again, our rule does not change if we have a variable in here instead of a number. So this is the same property, the same rule, except for we're now looking at this with a variable instead of a number. So this variable is k to the 7th to the 5th. So that k value has that double exponent. Our base number stays the same, and here our base number, instead of being a number, is a variable. So our base number is k. And again, power of a power, we multiply our exponents together, and we would get an answer of k to the 35th. So our property stays the same if it's a variable. Okay. Our variable is our base number, and power of a power, we multiply our exponents together to get our new exponent. And again, we're simplifying, so we're going to leave it there in terms of an exponent as k to the 35th. All right, so this next example is similar to the one we just looked at. So again, I would like you to pause your video real quick, try this one, and then you can restart that video to see if you got the right answer on this problem. So again, here our base number in our monomial is a variable. It is w. As you can see in all your answer choices, okay, our base number stays the same. We're still looking at w. What we need to find is what our exponent would be. All right, again, power of a power, that double exponent, we're going to take our exponent values and multiply them together. 4 times 6 is 24. So our answer here would be answer D, okay, w to the 24th power. All right, so these next two examples that we're going to look at add in one more piece, and this is something that was similar to what we saw when we were multiplying monomials is we now have a coefficient. And to go back some vocab here again, coefficient is that number that's attached to our variable. So when we have a problem that's set up like this, we have 2p to the third, and then that whole value is going to the fourth power. So when we have a setup like this, these two numbers can be looked at as being separate from one another. So the 2 is not attached to the exponent of a 3. However, everything inside of this parentheses is affected by this exponent of a 4. So that outside exponent goes to everything inside of these parentheses. So I'm going to break this into two pieces here. So we have our coefficient becomes 2 to the fourth power. And then we have p to the third. As our power of a power with that second exponent attached there. Now for our coefficient, we are going to solve out this exponent. Since it's going to continue to be our coefficient, we are going to solve that piece out to get our new coefficient. And then on the right side, this piece on the right side is the same as what we were just doing. So we're going to do those as two separate pieces to get our full answer here. So the first piece that I'll do here is 2 to the fourth. So again, 2 to the fourth is repeated multiplication. This means 2 multiplied by itself 4 times. So this is the same as 2 times 2 times 2 times 2. So we have 2 times 2 is 4, times 2 again is 8, times 2 one more time is 16. So 16 is our new coefficient. On the right side here, we have p to the third. Again, that base number is going to stay the same. So when we write up our answer, our base number here is still going to be p. And we have a power of a power. And whenever we have that double exponent there, we multiply those together. So our exponent here would be 12. That gives us an answer of 16p to the 12th. So the right side of this equation, the p to the third to the fourth, is the same as what we were just looking at. We multiply those exponents, the base number stays the same. The only added piece here is this left side where we take that coefficient to our exponent, which was 2 to the fourth, which got us our new coefficient of 16. So that left side is the only change here from the previous example. All right, so we have one last example problem here. This is similar to the one that we just looked at. We have the coefficient there. So this has a coefficient of 8, b to the ninth, and then that whole value is going to the second power. So one last time, I'd like you to pause the video, try this example problem real quick, and then restart the video and see if you got the answer right for this one. All right, so just like the last one, I'm going to take this exponent and it's going to go to both pieces here. So it goes to the 8 and it goes to the b. So I'm going to rewrite this again as two pieces. We have 8 to the second power. We have b to the ninth. again, that b to the ninth then goes again to that second power. So that double exponent up there goes to both pieces, the 8 and the b. 8 squared, again, this means repeated multiplication. So this is 8 multiplied by itself twice. So 8 times 8. And 8 times 8 gives us a new coefficient of 64. And then we have b to the ninth to the second. So again, just like our multiplication and division problems and the ones we've looked at so far today, that base number always stays the same. So this is still b. And our power of a power, we multiply our exponents, and this becomes 64b to the 18th. All right, so this is a new property of exponents. We're looking at power of a power, and make sure that when you come to class next time that you bring any questions that you have from today, or let me know if there was any of these example problems you tried on your own that you had trouble with, so that we can walk through them one more time when we meet. All right, so I'll see you guys when we meet again for our live session. Thanks for watching this video.